Welcome back to part 2 of determining if a first-order differential equation is homogeneous. In the previous video, we focused on the definition given by dy dx equals f of x comma y is homogeneous if f of x comma y can be written as a function of x to y or y to x. In this video, we're going to use the alternative definition that says a differential equation in the form dy dx equals f of x comma y is homogeneous if f of tx comma ty equals f of x comma y. So this definition here is helpful if the right side of the differential equation is fairly complicated or it's difficult to write it as a ratio of x to y or y to x. So let's take a look at our example. So to determine if this differential equation is homogeneous, we're going to let this right side be f of x comma y, and then we'll determine f of tx comma ty, and if it's homogeneous, it must equal the original function f. So f of tx comma ty means we're going to replace every x with tx and every y with ty. So we'll have tx times ty times e raised to the power of tx over ty. In the denominator, we're going to have tx squared plus ty squared sine tx over ty. Now let's see if we can simplify. We can write this as t squared xy times e raised to the power of, here we have a t over a t, that simplifies to 1. So we have e raised to the power of x divided by y. Looking at the denominator, we would have t squared x squared plus t squared y squared sine, and again here we have t over t that simplifies to 1, so we have sine of x divided by y. Now if we look at the denominator, notice how these two terms connected by addition have the common factor of t squared, so now we'll factor out t squared from the denominator. That's going to leave us with x squared plus y squared sine x divided by y. And now notice the numerator and denominator both contain two factors of t, or t squared, and t squared over t squared simplifies to 1. So now we have xy e to the power of x divided by y all over x squared plus y squared sine of x divided by y. And notice how now f of tx comma ty, once it's been simplified, is in this form, which is equal to the original function f of x comma y here. Therefore, we've shown that the given differential equation is homogeneous. So in most cases, we will show that a differential equation is homogeneous by showing that the right side can be written as a function of y divided by x or x divided by y. But in some cases, when the function f is complicated, we can use this technique as well. Okay, I hope you found this helpful.